Good evening to Puan Muzalifah. Today we are group 14 and we are going to be explaining about number system converter. So my name is Nisha Ana Pompom Balachandra. My ID card is B122310545. I'm going to be talking about number system converter. So a number system converter is a tool or program that converts a number from numeral systems such as binary, decimal, octal, and decimal to another, ensuring accurate representation across different bases of 40 languages. So the problem background for number system converter is a number system converter addresses the challenge of converting value between numeral system like binary, decimal, octal, and hexadecimal, each with different bases. These conversions are crucial in fields like computing, programming, and digital electronics, where systems represent data differently. Manual conversion can be error-prone and time-consuming, especially for large or fractional number, making automated tools essential for accuracy and efficiency.
Hi everyone, my name is Sashini Nair and I will be introducing our project today. So our project today is the number system converter, and it is a handy tool that makes it easy to convert decimal numbers between binary, hexadecimal and octal. These number systems are important in industries such as computer science and electronics. Manually converting numbers between these systems can be difficult and time consuming. This function simplifies that process, giving you quick and accurate way to convert number without a hassle. So basically, what this number system does is it converts the numbers, but only when it comes to decimal and fractions. And this system is actually quite useful because it when you manually convert numbers, you are prone to making more mistakes as a human. And this one is done by the computer, so it minimizes human error.
Hi, my name is Husna Zafira. Let me start with the objective of this project. The main goal is to develop a C program capable of converting numbers between different numbers system, binary, decimal, octal, and hexadecimal. To make the program user-friendly, we aim to design an intuitive menu-driven interface that makes interaction straightforward for users. Lastly, this project serves a practical coding exercise allowing us to apply fundamental programming concepts such as loops, conditions, and data validation. This objective will help us create a functional and educational tool for both learners and developers. Next, now moving on the scope of the project. First, let's talk about the limitation. The program can only convert a decimal number into equivalent in binary, octal, or hexadecimal. However, it does not support direct conversions between non-decimal systems such as binary to octal. Additionally, the program only supports integer numbers, meaning negative numbers and decimal fractions like 2 or 12.75 cannot be converted. Next, the target user for this program are students. This is perfect for students studying number systems as it simplifies conversion tasks. For educators, teachers and lecturers can use the program as a teaching aid or as example for simple C programming projects. For developers, it can also help developers verifying manual number conversions quickly while debugging. This program is tailored to meet the needs of its users while staying within the defined limitation.
Hello, my name is Hamsul Rubini, and today I'll be explaining about the flowchart that we used for this coding. So firstly, we begin with start. This is where the program will begin its execution. And after that, we have display menu. This is where the program will introduce the display menu to the user so that they can get familiar and know what choices there are for them to pick. We have 4 choices, which is binary, octal, hexadecimal, and also exit. After that, we will display an user input where we will ask the user to input a number, which is from 1 to 4. If the user inputs choice 1, they will input a decimal number and the conversion from decimal to binary will occur and the binary output will be displayed to them. If they choose choice 2, an input decimal number will be input and the conversion from decimal to octal will occur and the output will be displayed. If they choose choice 3, similar to before, they will input a decimal number and the conversion from decimal to hexadecimal number will occur and the hexadecimal output will be displayed to them. If they choose choice 4, which is exit, the user will choose to exit the program, hence the program will exit. And if they choose out of range, which is not choice 1, 2, 3, or 4, the program will go back to the start where it will go back to display menu and it will display the menu to the user again. This is where loop is used.
Hello everyone, I'm Regina. These are the C programs that we use to create the number system conversion calculator. In this program, we use function, do while loop, if, else, then we switch, and as if. At the top of the program, from row 5 to row 8 is the function declaration. The first 3 functions are convert a decimal number into binary, octal, and hexadecimal. The pengesahan input function ensures that the users enter a valid integer. Next, we define what each function does. A function definition contains the actual code that performs a specific task. Asas 10 kepada asas 2 is converts a decimal number into a binary number using repeated division by 2, stores the binary digits in an array, and prints them in a reverse order. Next, asas 10 kepada asas 8 converts a decimal number into an octal number using repeated division by 8. Again, the octal digits are stored in an array and printed in reverse order. Asas 10 kepada asas 16 is converts a decimal number into hexadecimal using repeated division by 10. If the remainder is less than 10, it converts it to a digit. Otherwise, it converts it to a letter A to F. Pengesahan input is the function that ensures the users inputs a valid integer. If the input is invalid, the program prompts the user to enter it. Now let's see how we call these functions in function call. The main function is the main function is from the switch function where there are 4 choices, case 1, case 2, and case 3, and then if the user selects 4, the programs will exit. The functions are called here to perform the desired conversion. To summarize, declarations tell the compiler what function exists, definitions specify how the functions works, and calls execute the functions. Next. These are the output that after we run the code. For example, we use the decimal number 12. Okay. Next.
Okay, so in conclusion, we can say that the number system conversion calculator is actually a very good helper. However, it does have some weaknesses. As my groupmate mentioned just now, we do have some limitations to these programs where the system only supports integers and negative or decimal fraction cannot be converted. So that's the weakness of the system. The program will only deal with valid inputs and will not do fractional numbers. Moreover, it is confined to a text-based interface, which might not be as visually appealing or intuitive to the users. Future improvements could be about fractional number conversion support and development of a graphical user interface (UI) to make the user experience seamless. And I think that's all from us. Thank you.